नमस्ते, सबको स्वागत है। इस वीडियो में थर्मल एनालिसिस के बारे में डिस्कस करेंगे, समझेंगे। There are three types of TGA, three types DGA, thermal analysis, three types है। Thermal gravimetric analysis or thermogravimetric analysis TGA, differential thermal analysis DTA, differential scanning calorimetry DSC. फर्स्ट थर्मल एनालिसिस क्या है? थर्मल एनालिसिस क्या कहते हैं? A physical or chemical property of the sample is measured against time or temperature. Okay, it is in thermal analysis we measure a chemical or physical property against temperature or time. Okay, समझेंगे? ओके, ठीक है। क्लासिफिकेशन ऑफ थर्मल टेक्निक, क्लासिफिकेशन टाइप्स ऑफ थर्मल टेक्निक्स। ओके, तीन टाइप्स है। थर्मोग्राविमेट्रिक एनालिसिस, दूसरा डिफरेंशियल थर्मल एनालिसिस TTA, तीसरा डिफरेंशियल स्कैनिंग कैलोरीमेट्री DSC. Okay, differential scanning calorimetry. What is called thermogravimetric analysis? TGA. What is called thermogravimetric analysis? It measures a change in weight or mass of a sample when it is heated or cooled. Okay, in this technique we measure change in mass or change in weight of a sample by heating or cooling. This is the experimental setup. For TGA. This is a balance. Okay, this is a balance. We have a sample. We have placed a sample here, and this is furnace where the sample is heated. The heating is, the temperature is linearly increased. Okay, when the sample is heated, it undergoes chemical reaction resulting in mass change or weight change. Okay, upon heating or cooling, either cooling or heating. Okay, now this we can plot mass of the sample as a function of temperature. In this, let us plot mass of the sample is plotted as a function of temperature. This plot is called thermogram. What is thermogram? A plot of mass versus temperature is called thermogram. Let us now study differential thermal analysis. What is DTA? Okay. In this case, in DTA measures temperature change between the sample and the reference. In TGA, we have measured the mass change. In this case, we measure the temperature change or temperature difference between the sample and reference during heating or cooling. Okay, this is the TTA plot, differential thermal analysis plot. In this case, the temperature difference, see here, this is the experimental setup for DTA. Okay, you have here in the sample, you have taken sample here and the reference here, and this is thermocouple sensor to measure the temperature. What is the temperature? Okay, now using this furnace coil, the furnace is heated. Okay, the furnace is heated. Now the temperature difference is noted. The temperature difference is noted. In the case of reference, there will be no reaction, whereas in the sample there will be thermochemical reaction. In the sample there will be thermochemical reaction occurring. Therefore, as a result, for example, if a thermochemical reaction occurring is exothermic, okay, heat is released, therefore the sample will be much hotter, the temperature will be higher. As you see, the temperature differential, the difference DT, that is temperature difference between sample and reference. As you see, because of exothermic reaction, the temperature increases. Therefore, here there is no reaction, so there is no change in temperature. Okay. So here the temperature is increasing because of the exothermic process. Suppose the sample undergoes endothermic change upon heating, then there will be endothermic. Here the graph will be inverted. Okay, this will be here like this. Therefore, the temperature, if it is endothermic, heat is absorbed by the sample. It is, in this case, in exothermic, heat is released, so temperature increases, whereas in endothermic process, the heat is absorbed by the sample, therefore the temperature decreases. Okay. The third technique is differential scanning calorimetry, DSC. In DSC, it measures heat absorbed by the sample or liberated during heating or cooling. That is, how much heat is absorbed by the sample when temperature is increased or when temperature is decreased, that is cooling. Okay, in this technique, we measure heat absorbed by the sample or liberated by the sample by heating or cooling. Heat absorbed means endothermic process, heat released means exothermic process. So this is the experimental setup. This is the same experimental setup used for DSC also. In TTA and DSC, the experimental setup are the same, because in this case heat is measured, in TTA temperature is measured. Let us quickly summarize the classification of thermal analysis techniques. TGA, it measures change in mass on heating or cooling of the sample. In TTA, temperature difference between the sample and reference are measured. In DSC, heat absorbed or liberated by the sample during heating or cooling. Let us see TGA instrumentation. The apparatus simultaneously heats the sample and measures its weight, called thermobalance. What is called thermobalance? It is an apparatus that simultaneously we heat the sample and also measure its weight. Okay. So this is the experiment. This is the TGA instrument. Okay. As you see here, you have sample holder where sample is placed and a temperature sensor. Okay. So temperature sensor to measure what is the temperature, because we are heating, how much we are heating we should know. And you have furnace, it is enclosed in a furnace, heating furnace, and furnace temperature programmer. This is and you have a recorder, because temperature is recorded, and also balance. You have balance here, the mass change is recorded here, and balance control recorder, and temperature sensor, furnace temperature. The temperature is linearly increased. The temperature is linearly increased by using furnace temperature programmer. We have a temperature sensor to measure the temperature. We have a balance to measure the change in mass by the sample upon heating. Let us discuss the principle of TGA. The substance under the sample or substance under examination is either heated or cooled at a controlled rate. At a controlled rate, the temperature is linearly increased. Okay, the weight of the substance is recorded as a function of temperature or time. That is, the weight of the sample is measured as a function of temperature or time. Okay. The plot obtained is called a thermogram. We have earlier seen. If the temperature varies during the study, then the weight is plotted as a function of temperature. If the temperature is constant, suppose you can keep the temperature constant, the weight is plotted as a function of time. The change in weight is used for quantitative analysis, and the temperature at which the change in weight takes place can be used for qualitative analysis. Okay. So, what is the drying temperature? It can be obtained from TGA for quantitative analysis, because for particular temperature, for example, you have nickel dimethyl chloride, gravimetric analysis. Okay, up to 120 or 130 degree, there will not be any change. Once you heat above that, there will be mass loss due to thermochemical reactions because of decomposition of the nickel dimethyl chloride. Therefore, the change in weight is used for quantitative analysis and also can be used for qualitative analysis. Affecting thermogravimetry. There are two factors affecting thermogravimetry. They are instrumental factors, one. The other one is sample characteristics of the substance we use for the study. Let us see the instrumental factors. For example, the thermogram will be affected by the heating rate. Okay. If the heating rate is very high, then some of the process will not be seen because of the high heating rate. So we need to heat at optimized heating rate. Furnace atmosphere. What is called furnace atmosphere? We use either air as in the furnace, or static air, or continuously passing dynamic air, continuously passing air through the furnace, or furnace atmosphere may be inert atmosphere, inert gas like argon. Okay. In the case of oxygen, in some cases oxygen will react with the sample. In such a case, inert atmosphere is used. Okay. Then sample holder. Depending upon sample holder, the thermogram will vary. It will affect our thermogram. Let us see how the characteristics of the sample affect TGA, thermogrametry. Weight of the sample affect the thermogrametry. Particle size of the sample. For example, you have micro-sized particles, nanoparticles. Then depending on the size of the particle, the thermogravimetry will depend on the particle size of the sample. It depends on the weight of the sample and heat of reaction. It also depends on the heat of the reaction, compactness of the sample, how it is packed, compactness of the sample. It also depends on source of the sample. For example, you can prepare compound calcium carbonate, okay, through two different methods. So the sample characteristics will also affect the the same calcium carbonate is obtained through two different synthetic methods. They will give different thermogravimetry. Please see that, okay. Classification of TGA curves, types of TGA curves. There are different types of TGA curves, okay. We'll see one by one. See, in this case, let us take A. There is no change in mass with respect to increasing temperature. For example, increase in temperature, and here mass, the x-axis mass. This is a thermogram, okay. Let us consider A only A, okay. In this case, with the increase in temperature, there is no change in mass. See, it's flat, okay. So, no change in mass over entire range of temperature. Okay. Let us take the TGA curve B. This is a second type of curve. Okay. In this case, there is desorption or drying of the sample. Mass loss is largely due to desorption or water drying, water removal due to drying, and followed by plateau. There is no change in mass. So this type of curve is obtained due to drying or desorption of the sample absorbed. Desorption of the gas absorbed on the sample. Okay, let us take the curve C. This is actual thermogram. Okay, where there is decomposition of the sample, where there is thermochemical reaction. Here there is no thermochemical reaction. Here there is physical change only. Here there is a decomposition of sample or compound or substance due to a chemical reaction. Okay, as a result of chemical reaction, there is a drastic change in the mass of the sample. See, mass. There is a decrease in mass. Mass is here. There is a decrease in mass. Okay. Single stage decomposition. Okay, now let us take this. See, here there is a small weight loss, and there is another weight loss and another mass loss. So this is a single stage decomposition process. In this case, 1, 2, it is a 3-stage decomposition process called multi-stage decomposition. Let us take this TGA curve. Let us take this TGA curve. See, here there is increase in mass of the sample because of increase in mass due to oxidation. For example, you have taken aluminum sample. Okay, aluminum, suppose it reacts with the oxygen, or if you take calcium metal, calcium will react with the oxygen to give calcium oxide. Therefore, its mass increased. This type of curve is obtained for samples which undergoes atmospheric reaction like surface oxidation. Okay. In this case, See, up to this stage it is like F, and then an oxide is formed. For example, you have iron oxide. Take iron oxide. Iron oxide is formed. Further heating, it decomposes to give iron or mercury. For example, mercuric oxide, and further heating, it decomposes to give iron. So similar, this curve is this TGA curve is similar to F, but product decomposes at this stage at further higher temperatures. Let us study the TGA of calcium oxalate, thermal decomposition of calcium oxalate. It occurs, the thermal decomposition of calcium oxalate occurs in 3 steps. In the first step, calcium oxalate is actually a monohydrate. It occurs as a monohydrate. In the first step on heating, okay, calcium oxalate anhydrous is formed by eliminating a molecule of water. Okay, in the second step, carbon monoxide is released. Okay, carbon monoxide is released to give calcium carbonate. In the third step, calcium carbonate is decomposed to give calcium oxide in the solid state plus carbon dioxide gas. Let us see the TGA curve of thermogram. Let us see the thermogram of calcium oxide monohydrate thermal decomposition. So let us plot weight versus temperature. In this case, there are 2 curves. This curve is called thermogram, TGA curve. Okay. There is another curve called differential thermogram. This is ordinary thermogram. This is differential. Blue color is differential thermogram. Okay. See, there are, as we have seen, there are 3 steps. In the first step, water is eliminated. Water is eliminated with increasing temperature. Okay, so this is the mass change. Mass decreases due to removal of water. Mass is decreased due to removal of, or due to loss of water molecule. Okay, and the differential curve dt, then you will get a peak at this point. So this is one peak, and then this drastic weight change corresponds to step 2 chemical reaction, and similarly you get a peak in the differential thermogram. Okay, and there is a third thermal decomposition process due to drastic mass change, and you see this is in the first step mass change is less. The third step mass change is large. The area under the curve gives area. For example, you see the area under the curve 1 is small because the mass change is small. From the area under the curve of differential thermogram, we can obtain the how much mass is lost. Okay. So these are the 3 steps which gives 3 mass loss. Okay, 3 thermo process. What are the reasons for weight change during heating of the sample? What are the mechanisms? So when there are 2 cases. There will be weight loss or weight gain. Weight loss is mainly due to these 4 processes. Decomposition. Okay, decomposition of the sample due to breaking of chemical bonds, evaporation, loss of volatiles water molecule with the elevated temperature or air adsorbed on it, reduction, interaction of sample with the reducing atmosphere, hydrogen, ammonia, we have used, if we have used reducing atmosphere, then reduction of the sample, okay, and then desorption. Due to desorption, there will be weight loss. We have seen in different types of TGA curves. And another case is, the second case is weight gain. When there will be, when the substance will gain weight, when there will be oxidation, interaction of the sample with an oxidizing atmosphere, formation of oxide layer, or absorption results in weight gain in thermogravimetry. In all these thermochemical reactions, the kinetics of this rate of thermochemical process can also be studied by using thermogravimetry. The rate of the process, rate of thermal process can also be studied by TGA technique. धन्यवाद, सबको धन्यवाद. प्लीज़ सब्सक्राइब कीजिए एंड शेयर कीजिए. धन्यवाद.